Welcome back. Let's read about this old engine. There's many good links, a lot of good links.
Hispano-Suiza 8. The Hispano-Suiza 8 is a water-cooled V8 SOC aero engine introduced by Hispano-Suiza in 1914 that went on to become the most commonly used liquid-cooled engine in the aircraft of the Entente powers during the First World War. The original Hispano-Suiza 8AM was rated at 140 HP, 100 kilowatts, and the later, larger displacement Hispano-Suiza 8F reached 330 HP, 250 kilowatts. Hispano-Suiza 8 engines and variants produced by Hispano-Suiza and other companies under license were built in 21 factories in Spain, France, Britain, Italy, and the US. Derivatives of the engine were also used abroad to power numerous aircraft types, and the engine can be considered as the ancestor of another successful engine by the same designer, the Hispano-Suiza 12Y, and Soviet Klimov V12 derivative aero engines, which was in service during the Second World War. Design and develop Hispano-Suiza 8. The Hispano-Suiza 8 is a water-cooled V8 SOC aero engine introduced by Hispano-Suiza in 1914 that went on to become the most commonly used liquid-cooled engine in the aircraft of the Entente powers during the First World War. The original Hispano-Suiza 8AM was rated at 140 HP, 100 kilowatts, and the later, larger displacement Hispano-Suiza 8F reached 330 HP, 250 kilowatts. Hispano-Suiza 8 engines and variants produced by Hispano-Suiza and other companies under license were built in 21 factories in Spain, France, Britain, Italy, and the US. Derivatives of the engine were also used abroad to power numerous aircraft types, and the engine can be considered as the ancestor of another successful engine by the same designer, the Hispano-Suiza 12Y, and Soviet Klimov V12 derivative aero engines, which was in service during the Second World War. Design and development, edit. Origins, edit. At the beginning of World War I, the production lines of the Barcelona-based Hispano-Suiza Automobile and Engine Company were switched to the production of war material. Chief Engineer Mark Burkigt led work on an aircraft engine based on his successful V8 automobile engine. The resulting engine, called the Hispano-Suiza 8AM, HS31, made its first appearance in February 1915. The first 8AM kept the standard configuration of Burkigt's existing design, 8 cylinders in 90 degrees V configuration, a displacement of 11.76 liters, 717.8 cu in, and a power output of 140 HP at 1900 RPM. In spite of the similarities with the original design, the engine had been substantially refined. The crankshaft was machined from a solid piece of steel. The cylinder blocks were cast aluminium and of monoblock type, that is, in one piece with the SOC cylinder heads. The inlet and exhaust ports were cast into the blocks. The valve seats were in the top face of the steel cylinder liners, which were screwed into the blocks. Using a rotating bevel gear-driven tower shaft coming up from the crankcase along the rear end of each cylinder bank, with the final drive for each cylinder bank's camshaft accommodated within a semicircular bulge at the rear end of each valve cover. Aluminium parts were coated in vitreous enamel to reduce leakage. All parts subject to wear, and those critical for engine ignition, were duplicated: spark plugs for dual ignition reliability, valve springs, magnetos, etc. Engine reliability and power-to-weight ratios were major problems in early aviation. The engine and its accessories weighed 185 kilograms, 408 pounds, making it 40% lighter than a rotary engine of equivalent power. This empty weight does not include the radiator and coolant fluid. Generally, air-cooled engines are lighter than their equivalent horsepower water-cooled counterparts. For example, the Bentley Brother 2 rotary put out 230 HP, 170 kilowatts, and weighed 220 kilograms, 490 pound. Clerget 9B rotary 130 HP, 97 kilowatts, 173 kilograms, 381 pound. The new engine was presented to the French Ministry of War in February 1915, and tested for 15 hours at full power. This was standard procedure for a new engine designed to be admitted into military service. However, because of lobbying by French engine manufacturers, the Spanish-made engine was ordered to undergo a bench test that no French-made engine had yet passed, a 50-hour run at full speed. The HS-31 was therefore sent back to Chalet-Moudon on the 21st of July 1915, and tested for 50 hours, succeeding against all expectations. The design also promised far more development potential than rotary engines. This was despite being the most common type, then in use, for most aircraft. Also, rotary engines were getting close to the limits of their development at this time. Rotary engines of increased power generally had increased weight, which in turn increased the already serious gyroscopic torque generated by the engine's rotation. A further increase in torque was considered unacceptable, and the power-to-weight ratio of the new rotary engines under development did not appeal to aircraft designers. French officials ordered production of the 8AM to be started as soon as possible and issued a requirement for a new single-seat high-performance fighter aircraft using the new engine. The Louis Bachot-designed Spad 7 was the result of this requirement and allowed the Allies to regain air superiority over the Germans. Variants, edit. Some data from British piston engines and their aircraft. Note: Hispano-Suiza company type numbers were prefixed by HS or written in full as Hispano-Suiza Type 31, but military designations used the conventional system of Hispano-Suiza, engine manufacturer, 8, No of cylinders, A, engine series, B, variant, R, attribute, thus Hispano-Suiza 8AB. 8, HS31. 100 kilowatts. 140 HP, initial production and test engines, with few applications, including early Newport 14S. 8AA, HS31. 110 kilowatts, 150 HP, at 2000 RPM, entered production in July 1915. Early HS-8A engines were plagued with various problems which required further work and was the standard power plant for early production Spad VIIs and the Curtiss Jenny JN4H variants. The demand for the Hispano-Suiza engine was such that other manufacturers began producing it under license, in France, Great Britain, Wolseley-Ada, Italy, Nagliati in Florence and Itala /Scat. Automobile, in Turin, and Russia. Total production of the HS-8AA amounted to some 6,000 engines. 8AB, HS-34. 130 kilowatts, 180 HP, at 2,100 RPM, increasing the compression ratio from 4.7 to 5.3, Burkigt was able to increase the power output. The 8AB began replacing the 8AA on Spad VIIs in early 1917. 8AC. 8AD. 1929, 120 mm 130 mm, 4.7 in 5.1 in, bore X stroke, 160 kilowatts, 210 HP, for takeoff. 8B, HS-35. 150 kilowatts, 200 HP, compression ratio 5.31, geared at 0.751, The HS-36 was the 8B with a Lewis gun firing through the propeller boss. 8B twin, HS-39. Coupled 8B engines. 8BA. 150 kilowatts, 200 HP, at 2,300 RPM, low compression ratio of 4.71, spur geared at 0.5851. 8BB. 150 kilowatts, 200 HP, compression ratio of 4.81, reduction gear 0.751. However, the reduction gear system was fragile, and often broke down, sometimes with spectacular results ending up with the entire propeller, drive shaft and driven gear parting company from the airframe. Progressive refinement of the engine brought the available power to 175 kilowatts, 235 HP, by the end of 1917. The 8B, 8BA and 8BB were used, A, to power the earliest versions of the S.E.5A, B, along with the 8BD, the SPAD S.13, C, frontline active versions of the SOAP with Dolphin, and D, several other Allied aircraft types, with its gear reduction easily identifiable in vintage World War I photos, from its use of a clockwise, viewed from in front, otherwise known as a left-hand tractor, rotation propeller. 8BC. 160 kilowatts, 220 HP, compression ratio of 5.31, reduction gear 0.751. 8BD. 160 kilowatts, 220 HP, compression ratio of 5.31, reduction gear 0.751. 8BDA. 8B. 160 kilowatts, 220 HP, compression ratio of 5.31, reduction gear 0.751. 8BEC, HS-38. The 8B fitted with the 37mm, 1.457 in, sunk Model 37 cannon, or a similar weapon, firing through the propeller boss. A reduction gear-equipped power plant with a resultant clockwise rotation propeller like the 8B, produced 160 kilowatts, 220 HP, at 2,100 RPM. Two known weapons fitted were the sunk with a rifled barrel and a smoothbore cannon firing canister ammunition. The motor cannon could fire a single shot at a time through the hollow drive shaft without propeller interference. This cannon mount required an elevated intake manifold design, bringing the intake runners straight off the inner surfaces of the cylinder banks to the updraft carburetor's plenum chamber. The engine was used on the SPAD S.12. 8CA/220. Cannon equipped 168 kilowatts, 225 HP, at 2,100 RPM with 5.31 compression. Given the company designation HS Type 38. 8CB/180. Cannon equipped 160 kilowatts, 220 HP, at 2,000 RPM with 4.71 compression. Given the company designation HS Type 44. 8cc/220. Cannon equipped 160 kilowatts, 220 HP, at 2,100 RPM with 5.31 compression. Given the company designation HS Type 44. Hispano-Suiza Type 40. 8E. Hispano-Suiza Type 41. 8AM. 8F, HS42. 220 kilowatts, 300 HP, at 2,100 RPM, x 750 pound-feet torque. The direct drive 8F was a bored-out version of the 8B, intended for use in bombers, with a displacement of 18.5 L, 1,128.94 cu in. Despite the increased weight of 564 pound, 256 kilograms, the 8F was also installed in fighters such as the Nieuport Diliajna D-29 and Martin Sid Buzzard, and would have powered the never-produced Mk.2 version of the Soap with Dolphin. Engine speed being lower than that of the HS-8B, the reduction gear was deleted, thereby increasing engine reliability. 8FA. Generally similar to the 8F. 8FB. 220 kilowatts, 300 HP, aka HS Type 42, compression ratio of 5.31, direct drive. 8FD Special. For the CAMS 38 Schneider Trophy Racer developing 280 kilowatts, 380 HP. 8FE, HS42 VS. 1926. 140 mm 150 mm, 5.5 in 5.9 in, bore X stroke, 260 kilowatts, 350 HP, for takeoff. Wolseley W.4 Python I. 110 kilowatts, 150 HP, compression ratio of 4.71. License production of the 8AA at Wolseley Motors Limited. Wolseley W.4 Python 2. 130 kilowatts, 180 HP, compression ratio of 5.31. Wolseley W.4 Viper. 150 kilowatts, 200 HP, compression ratio of 5.31. Wolseley's engineers removed problems with the crankshaft and increased the compression ratio to give more power, with some early engines having a compression ratio of 5.61. Wolseley W.4 Viper 2. 160 kilowatts, 210 HP, at 2000 RPM. Wolseley W.4 Beader I. 150 kilowatts, 200 HP, compression ratio of 4.71, reduction spur gear to 0.5931. Wolseley W.4 Beader 2. 150 kilowatts, 200 HP, compression ratio of 4.71, reduction spur gear to 0.5931. With stronger crankshaft webs. Wolseley W.4 Beader 3. 150 kilowatts, 200 HP, compression ratio of 4.71, reduction spur gear to 0.5931. With balanced crankshafts. Wright Hisoa. Wright Martin build type 34 /HS8AA 150 HP, 112 kilowatts, at 1400 RPM and 4.721 compression. Wright Hiso B. 4CYL inline water-cooled 56 kilowatts, 75 HP, 120 mm 130 mm, 4.7 in 5.1 in. Wright Hiso C. 150 kilowatts, 200 HP, Beardo. Wright Hiso D. 150 kilowatts, 200 HP, Beardo with cannon. Wright Hiso E. 130 kilowatts, 180 HP, at 1700 RPM and 5.331 compression, HCI. Wright Hiso E2. HCE. Wright Hiso F. D without cannon. Wright Hiso H. 220 kilowatts, 300 HP, based on the Type 42 /HS8F. Wright Hiso H2. Improved H. Wright Hiso I. Wright Hiso K. H with 37 mm Baldwin cannon. Wright Hiso K2. Wright Hiso M. Experimental 300 HP. Wright Hiso T. Wright Hiso 180 HP V8. direct drive. Right Hisso 220 HP V8. Gear drive. Right Hisso 300 HP V8. Gear drive. M6. A 220 kilowatts, 300 HP, Soviet Union produced copy of the 8FB. Right Hisso V720. Applications, edit. 1 Austin Baller.F.B.1, single prototype. 2 Avia BH21, from 1925. 3 Avia BH22. 4 Bartle BM5. 5 Bernard Sim AB10. 6 Blanchard BRD.1. 7 Caudron R.11, 8 B. 8 Caudron C.59. 9 Caudron C.61, 8 AC. 10 Curtis JN4H Jenny, rare subvariant. 11 De Bruyere C1. 12 D Scamps 27, 8 FB. 13 Duoitine D.1, 8 FB. 14 Farman F.121 Jabiru, 8 AC. 15 FBA Type H, 8 AA. 16 Felix Stowe F.1. 17 Fopka D.9. 18 Fopka D.X, 8 FB. 19 Fopka D.12, 8F, initial design only. 20 Fopka S.3. 21 Gerduli Sir GL.21. 22 Henriette HD.5. 23 Henriette HD.15. 24 Henriette HD.20. 25 Ito EMI 29. 26 Letered LED.1, 8 AM. 27 Letered LED.2 and LED.3, 8 BA. 28 Letov 7, 8 FB. 29 Letov 13, 8 FB. 30 Letov 14, 8 FB. 31 Levasseur PL.1, 8 AB. 32 Martin Sid F.4 Buzzard, 8 FB. 33 Newport 14, 8 AM. 34 Newport Deliagna D29, 8 FB. 35 Newport Deliagna D38, 8 AB. 36 Newport Deliage Sesquiplan, 8 FB. 37 Royal Aircraft Factory S.E.5, 8AA, and S.E.5A, 8B, 8BA or 8BB on earliest versions and the Wolseley Viper derivative on later models. 38 Soap with Dolphin, 8B. 39 Soap with B.1 prototypes, 8BA. 40 Spard S.7, 8 AM. 41 Spard S.11, 8B. 42 Spard S.12, 8 CB. 43 Spard S.13, 8B. 44 Standard J1, post-war modification. 45 Waco DSO, 8 AM. 46 Wibord 1, single prototype. Wright Hispano E, edit. 1 Boeing NB2. 2 at 3. 3 Consolidated PT1. 4 Cox Clement TW2. 5 Curtis at 4. 6 Dayton Wright TW3. 7 Huff Dalen TW5. 8 Loaning M8. 9 Naval Aircraft Factory TS3. 10 Travel Air 3000. 11 Vout VE7. 12 Waco DSO. Mitsubishi Hi-Shiki, edit. 200 HP, 8B. 1 Yokozuka Rogo Kyogate. 2 Hansa Shiki Switch Tai Satsuki, type Hansa Surveillance Float Plane. 300 HP, 8F. 1 Mitsubishi 1MF. 2 Mitsubishi 2 Mr. Comparative table, edit. Model 8AM 8AA 8AB 8B 8F. 4 mm, 120 140. Stroke, millimeter, 130-150. Displacement, L, 11.76 18.47. Compression ratio 4.75.3. Length, M, 1.19 1.25 1.31 1.36 1.32. Width, M, 0.81 0.83 0.85 0.86 0.89. Height, M, 0.77 0.81 0.87 0.90 0.88. Weight, kilogram, 195 215 230 236 256. Power output, HP, 140 150 180 200 /235 300. At, RPM, 1900 2000 2100 2300 2100. Engines on display, edit. 1. A Hispano-Suiza 8AA Type 34, made in 1916, is on public display at Museo de Aeronáutica y Astronáutica at Madrid, Spain. 2. A Wright Hisso 8AM is on public display at the Aerospace Museum of California. 3. A Wright Hisso 8AM is on public display at the National Museum of the U.S. Air Force. Specifications, Hispano-Suiza 8AM, edit. General characteristics. 1. Type, 8-cylinder liquid-cooled V-piston engine. 2 bore, 120 mm, 4.724 in. 3 stroke, 130 mm, 5.118 in. 4 displacement, 11.76 L, 717.77 in. 5 dry weight, 202 kilograms, 445 pound. Components. 1 valve train, SOC, single overhead cam. 2 fuel system, 1 Claudel or Zenith updraft carburetor. 3 cooling system, liquid. Performance. 1 power output, 150 HP, 112 kilowatts, at 1700 RPM. 2 fuel consumption, 310 G / kilowatt H, 0.51 pound / HPH. 3 oil consumption, 18.2 G / kilowatt H, 0.03 pound / HPH. See also, edit. Related development. 1 Harkis Hornet, a single bank of the Hispano-Suiza, on an Australian-made crankcase. 2 Wolseley Viper. Comparable engines. 1 Sunbeam Arab. Related lists. 1 List of aircraft engines. References, edit.